welcome to this module. Here we will be looking at where exactly the MEMS based sensors are used and what are the additional application of those sensors, and finally we will conclude this particular lecture series saying that how MEMS based sensors, understanding of MEMS based sensors and actuators can be useful for several applications. Okay. So, if you talk about MEMS based sensors, MEMS stands for micro electromechanical systems, micro stands for 10 raised to minus 6, minus 6 the order, if you want to understand, it is similar to the human hair thickness is close to 80 to 100 microns, 80 to 100 into 10 to the power minus 6. So, this is the thickness that we are talking about, from few hundred microns to few microns. And when we talk about such a smaller miniaturized sensors and actuators, where are they actually used? If you just take an example of a automobile, then if you take an example of a car, then there are several sensors in your car. So, if you see the slide, what you understand that in a given modern car, you will have plenty of sensors. We start with few, and lot of these sensors will also see in terms of process flow in this particular class. We have the initial navigation sensors, there is a accelerometer, there is a yaw rate, then there is a fuel injection system, right. This is for nozzles for fuel injection system. Then we have air conditioning compressor sensor, we have a manifold air pressure sensor, we have a mass flow, the airflow sensor, then we have 4 sensors for brakes and throttle vesicles, accelerometer for suspension, pressure sensor, inner sensor for braking control, we have tire pressure sensors, we have exhaust sensors which are gas sensors, and we have crash sensors, we have fuel sensors, airbag sensors, micromachining accelerometers, microphone for noise cancellation. So many sensors into one automobile when you get it. And a lot of sensors will be also looking at how to fabricate it. For example, we will look at the pressure sensor, we will look at the flow sensor, we will see how it can be used for a gas sensor, this MEMS based device. We will for vapor pressure sensors, right. We can say of microphone as well. So, lot of things that we will learn in this particular, again there is a pressure sensor here. What you learn here in this course can be utilized for several applications, excluding biomedical. It can be used for automobile industry, as you can see right over here. Now, if we talk about gas sensors, right, it becomes very simple, and we have discussed in one of the modules. If you want to design a gas sensor, what you require is that you should have a substrate, right, you should have the contact pads, and you should have the sensing material on the contact pads, right. This becomes your, so if it is this silicon, then we say that this is on oxidized silicon wafer, right, like this. You have SiO2, silicon wafer, SiO2, and you have interdigitated electrodes. This is your sensing material, sensing material, correct. So, you have interdigitated electrodes, you have silicon dioxide, you have silicon wafer, you have sensing material. Now, if you want to improve the sensitivity, the sensing material does not work at room temperature, you can add the heater to this. You can add a heater to it. If you add a heater to it, then you have to perform a micro machining. So, in that case, if you want to add the heater, then this will be like, you have a heater, right, you have a silicon dioxide. On heater, there is a contact to the heater, there is a cross section, do not worry about it, and then you have the, since you have a heater, you want to make sure that it heats at lower temperature. For that, you can create a diaphragm, right, and this becomes your sensor. This sensor, depending on the sensing material, you can use it for measuring the exhaust gases, right. So, this is a very quick example of how can you design a gas sensor, right, for such a vehicle system. You can design a pressure sensor, you also have the similar kind of work, you have the strain gauge, or you have a pressure sensor, I will have oxide layer, you have contact pad, and then you apply a force here. If it is a strain gauge, then depending on the bending of this diaphragm, the strain will change, and you can measure the strain using these contact pads, right. Pressure sensor, so easy to fabricate, right. It requires only 2 mask process to fabricate, and these things we will be learning in the course in next few modules. Now, what are additional applications of these MEMS? So, additional application are in the area of RF, radio frequency MEMS. It can be radio frequency switch. It can be in the area of optical MEMS, where we are looking at optical mirrors, switches, micrometers, bistable mirrors, laser scanners, optical shutters, as well as dynamic micromirror displays. While if you talk about RF MEMS, then it can be used for radio frequency switches. It can be smaller, cheaper, better, and then there is a reliability issue, but you know, getting there, since there is a lot of failure while fabricating the device. But if you see the slide, what you observe is that if you talk about a clamped beam micromechanical resonator, this beam is clamped from 2 different regions, and this is the anchor, right. These are electrodes for applying the voltage. When you apply a voltage, this mechanical beam will resonate, right, and the resonation will be in this particular direction, right. So, it will resonate in this direction. In some of the cases, when you develop the switch, it will resonate in this direction, right. So, this can be a micro resonator, or it can be work as a RF MEMS, and it will only work at a frequency of 8.5 megahertz resonating frequency. This is an example of the mirror. You can see that there is a slider, there is a mirror, there is a support, and there are hinges. It is a micro mirror, that the SEM of micrometer, this is SEM of your resonator. So, in conclusion, what we have understood about this particular lecture, which was focused on MEMS, is that MEMS are systems which are in a 1 to 100 micrometer range, and that can convert the electrical energy to mechanical energy and vice versa if you are talking about piezoelectric. But if you are talking about piezoresistive, then you apply pressure, which is mechanical energy, to resistance, again mechanical to electrical. The 3 basic steps in MEMS fabrication are deposition, patterning, and etching, right. So, deposition you can use PVD, CVD, we will talk about PVD, CVD. For etching you can use chemical etching, which is a wet etching, as well as dry etching. For patterning you can use photolithography. Photolithography, you have positive photoresist, negative photoresist, bright field mask, and dark field mask. Then due to their small size, they exhibit a very certain characteristics, and their microequivalents cannot produce that kind of characteristics. So, that is the advantage of MEMS. Finally, another advantage is in speed, complexity, power consumption, its device area, and system integration. So, these are another advantages of MEMS over their counterparts, which are macro in dimensions, and this benefits MEMS as a great choice in as a device in several applications and in numerous fields. We are talking about automobile, we are talking about communication, we can use the MEMS in medical and several other applications. So, it is really important to understand this particular part of a bigger umbrella, which is electronic systems. A part of this is MEMS, and MEMS based devices and sensors are used in several fields, right. This is a summary for you that any system that is between 1 to 100 micrometer, we can call it MEMS. The system generally transforms the electrical energy to mechanical or vice versa. The system is faster, miniaturized, it is a lower power consumption, its device area will be lesser, it is easy to integrate in a system. And finally, the step for fabrication of MEMS based sensors, there are 3 main steps. One is deposition, second is patterning, and third one is etching, right. So, this is all for this particular module. In the next module, we will be looking at how silicon is fabricated from silicon mold or silicon bowl, and then We also can see how we can grow silicon dioxide. But before that, if I want to give you 5 important key concept about MEMS, then here are those. The first concept is MEMS are made up of microelectronics, micro actuators, micro sensors. This is the first key concept. So, microelectronics, micro sensors, micro actuators and microstructures, these 4 things constitutes a MEMS. Again I am repeating: microelectronics, micro sensors, micro actuators and microstructures. The second key concept in the area of MEMS is 3 basic steps: deposition, patterning and etching. The third key step is chemical etching is popular because of its high etching rate. Fourth step is 3 types of pressure sensors are there. One is capacitive pressure sensor, then there is a piezoelectric pressure sensor and then there is a thermal pressure sensor. Right. So, 3 kind of MEMS based transducer, if you want to say: thermal transducer, piezoelectric transducer and you have capacitive transducer. Finally, the fourth concept I will say is that the or fifth concept is that the benefits of MEMS are speed, consumption, size, system. So, again if you want to see 5 key concepts, first concept is it is made up of microelectronics, microstructure, microactuators. The second concept is deposition, etching and patterning are the important steps. Third is chemical etching is faster, it is more preferable because of the high etching rate. Fourth one is there are 3 types of MEMS based transducer: capacitive, thermal and piezoelectric. And the fifth one is that the speed, power consumption, size and the system integration all on one chip is beneficial. Right. So, these are the 5 key concepts for the MEMS. Here we will stop our lecture and I will see in the next lecture talking more about silicon as a substrate. Till then you take care, have a nice day, bye.